What's up, car audio champions? Today we're taking a closer look and getting more in depth at the DSP settings on the Expert Px2 Connect. But this information will also cross over into other car audio electronics DSPs as well. So stay tuned. What's up, guys? So this video is for the guys that have questions about how to hook up, a DSP or this Expert series DSP specifically. Some of you guys may know this information, so if you know it, that's great. This is for the guys that don't understand it all, so hope this video helps. So let's go ahead and get started. The power requirements on this are really small. It only draws about 0.5 amps, so you can just connect to whatever's convenient, and then you can put like a 2 amp inline fuse and that'll be fine. Now it does have the remote in, so that'll be basically your 12 volt key on power source. Now if you already have your system wired and you're just adding this, you can come off your amp and go right into the remote in. So the remote from your amp to the remote in here, or you can rewire it and run the remote in to the DSP first and then use the remote out and go to your amp. Basically what that is you're turning on the DSP, and then in turn it will send out the remote signal and turn on the amp. Either way you want to do that, that's fine. The other question I had was, what's the preamp voltage output? It's adjustable, so this doesn't have a set preamp voltage output. It'll vary by your preamp voltage. So if you have a very low preamp voltage, like 1 volt, this will bump it up to maybe 3 volts or so, and these are just approximate numbers, and it can also drop it down to 0.5. But if you have a really low voltage RCA coming in, it's limited on what it will amplify it to. But like if you had a 5 volt, then you could probably go up quite a bit higher, and drop a little lower. So it's dependent on what you're providing it, but it is adjustable, so there's no set output voltage on the RCAs. The app works really well. Trying to use this DSP without the app is a little difficult. It's a little bit annoying to try to scroll through with the dial and do the settings, so you guys are going to be using the app anyway, so that's no big deal. When you first log into the amp, the stock password is just 0000, so just all zeros. So let's go ahead and get into the first section. So we have the app opened up, and your first section is the routing. So this is going to depend on what you're running. So if you're just running like a 4-channel amp for your 4 door speakers, then you can use channel 1, 2, 3, and 4. And you just want to make sure that, since those are stereo outputs, that you want to run a left and a right. So if you're going to use channel 1 and 2 for your front door speakers, you want to make those a left and a right. And then on the other RCAs, your 4-channel amp, you want to make those a left and a right also. So basically, if you're running a stereo RCA, you just want to make sure that you have your left and right output, so that way you keep your stereo separation. If you're running like a non-stereo amp, like a Brazilian full bridge that just has 1 input, then you can just select left and right, and it won't give you the stereo separation, but it will give you both the RCA inputs coming out on that channel together as one. So let's say you had a 4-channel amp on 1, 2, 3, and 4, and then let's say you have a standard half bridge subwoofer amp that has 2 RCA inputs. You can use 5 and 6. Same thing with that. So if you have a stereo half bridge amp, even if it's mono, a lot of them have 2 RCAs in, then you can do left and right. You can do both because stereo subwoofer is really not left and right channel, it's usually mono. But if it's 2 RCA's in, you can just keep it simple, leave it left and right. And let's say you just had one full bridge amplifier and you were going to run that on channel 6. So most full bridges only have one input, so then you would just do left and right. Again, it wouldn't matter really if you did it left or right, but it's better if you're just having a single signal to do left and right. And you can configure that any way you like. So basically it gives you the 6 outputs, and then if you're going to keep the stereo separation or non-stereo separation, you could just do left and right on one output. So that's pretty self-explanatory. The next is gain. Now, as you guys know, there's lots of videos out there how to set your gain. I'm assuming your gain is already set and you're adding this to your system. So basically I would start with setting all the individual channel gains to 0, so that way you have a little bit of room both ways to play with. Now, to set your main gain, you basically want to do a test. If you don't have an oscilloscope, you guys that do, then you guys already know how to do this, but this is for the guys that don't. If your system's already set up, you want to have, let's say this is hooked up to a subwoofer and you're adding this and you're only using it for a subwoofer because you have your factory head unit and you're using your factory door speakers. Set the volume to like halfway, crank some music without the DSP, listen to the subwoofer, note how loud it is, and then run it through the DSP, and then adjust your gain to where it sounds similar. You can just do it by ear like that. You can download a decibel meter app. There's a lot of free apps out there. Put it on your phone. You know, set it somewhere in the cabin, the same exact spot, and do it like that, and go off the decibel meter and adjust the gain to where the level's the same without the DSP and with the DSP. You could also just, if your amp has a clip light, you can go by clipping. So with your stock deck, crank a song or a test tone to where it just clips, and then hook up the DSP now, and you can start low and then go up until it just starts clipping, and then you know your gain is set pretty much the same as it was without the DSP. The other trick you can do, if you have an AC voltmeter, turn your volume, you know, halfway or 3/4 of the way. Usually it works best if it's 3/4. Play a 40, 50, or 60 hertz test tone, and again, there's free apps for that. And then using an AC voltmeter, check your voltage on your preamps coming out of your head unit. So let's say they're 2 volts playing that a 40 hertz test tone at 3/4 volume on your car stereo. So now you can hook the RCA's up to the DSP and you can check your voltage. So let's say you have a full bridge, so you're using a single output on channel 6. You can check the voltage on that and raise and lower the gain until the voltage was the same as the head unit preamp voltage. So those are just some easy ways to do it if you don't have an oscilloscope. Like I said, some guys do, some guys don't, so I just wanted to give you that little bit of input on setting the gains. So let's go back and let's go ahead and jump to the crossover section. So this is one of the coolest features, I think, on these DSPs, because crossovers make such a big difference, and they actually have more of an impact on sound than just what frequency they're cutting things off at. So you have, in this DSP, you have 3 different types of crossovers. You know, you have the Butterworth, and you'll see that by the BTW. You will have the Linkwitz Riley, and that's LKR. And then they give you 2 Bessels. And I'm not going to get into this. It's pretty complicated because they all have different sound characteristics. They were developed by different people. They have different spikes at the cutoff frequency. But in a nutshell, So this is just keeping it simple. If you guys already know this, then don't worry about it. Butterworths tend to be the smoothest, Linkwitz Riley's kind of in the middle, and then the Bessels have the sharpest cutoff slope. And the cutoff slope is what is the biggest difference on these settings. So let's say we're using let's say we're using a 12 decibel Butterworth. So you can see it has a nice round slope. So that'll give you some, it won't just stop at the 30 hertz. It gradually calms down, so you still get those fill-in tones. But if you wanted to cut it off sharper, then let's say you go to a 24 decibel Butterworth and see how sharp it chops it off. So depending on your system, there's no exact one's better than the other. Depending on your system, one may sound better in your car or vehicle than the other. It's less critical on those lower frequencies, because usually if you're cutting off at 30 hertz, you know, you don't care going under. It's really not that audible, and a lot of subs you know, don't go too far, you know, under 20 hertz anyway. So it's less critical on the low side. And if you guys just want to play safe, like the 12 decibel Butterworth is a pretty safe setting for both of these, on the low cutoff and the high cutoff. And we're using 100 hertz here just so the graph spreads out further. I usually cut off my subs at 80. I usually go like 30 to 80, but we're using 100 here. So there's a 12 decibel Butterworth on both, so you have a nice smooth slope. And you can see at 100 hertz it still produces over 100 hertz, but it tapers down nice and smooth. And that smooth curve allows for it to tone down those frequencies, but you still get them slightly and they drop off. So that tends to be a smoother sound. It blends well instead of a sharp cutoff. Because if you can see right here, like a 24 decibel Butterworth, it cuts off really sharp. And if your door speakers aren't really going that low in the mid bass section, then you might hear that little bit of a gap. So if you have that covered, no problem. But if you want to add that in and smooth it out to give it a fuller sound and make it blend well, then you could use something with a more gradual slope. And so here we have a 24 decibel Linkwitz Riley. Again, you can see how sharp that cuts off. And then the 24 decibel Bessel, again, it cuts off sharp too. So besides the cutoff slopes and how sharp they are and how quick they chop off the signal, they do have different sound characteristics. And like I said, that's in depth. I'm not going to go over it all, but I suggest trying each one, and you'll see the sound. You'll hear the sound characteristics right away, and then you'll be able to see what you like. So, and then, you know, if you have, this is just for sub, but we're messing with right now, but if you had separate, like a full range amp, then, you know, your full range amp for your door speakers, you know, you can cross that over at like 120 hertz, 100 hertz, but again, I can't tell you because your speakers are going to be different, your car is going to sound different, but you would just, you know, go to your other channel and then do the same thing for each channel. So, and it's done by each channel. So if you have a 4-channel amp, then basically you would want to do 1, 2, 3, and 4 the same, because if all the 4 door speakers are the same, you would want to match them up the same. So just keep that in mind. So next section, limiter. It's pretty self-explanatory. This gets a little in depth, but it's just a limiter, so you can basically set, you can crank your system as loud as it'll go, as loud as you want it to go, to where you're not going to start clipping and blow your speakers. So you can set that here with the threshold. And see how this automatic is selected. I would leave that set if you're going to use this. If you uncheck it, now the attack and the decay are selectable. And that gets a little more confusing. You guys can read up on that. But the attack is the initial stage that dictates the time it takes for that particular sound to rise from its minimum to its maximum value. Okay, so when you play a note, like attack will set a time it takes for the note to fade into full volume. And if you set your attack to be too long, you'll get a slow fading effect before it reaches peak. And if you set it to be too short, then the highest maximum note will be instantly hit without like a smooth gradual. And then the decay comes into play as soon as the attack reaches its peak. Okay, so once that happens, the decay will bring the volume down to the safe level. So if you guys want to read more on that, you can, but I would just recommend setting that on auto. It does a pretty great job already on auto of configuring that correctly. And again, if you're using multiple channels, you can set that up for each channel. So if you want, you know, if your sub's really hot and you got to limit the threshold a little earlier than your door speakers, it's all adjustable for each channel, which is nice. And then EQ in. So this is, you know, pretty self-explanatory. It's your graphic equalizer. So you can just go through and tweak this if you feel like you're missing something or you have too much of a certain frequency in your system. You can start going in here and playing around with these, you know, until it sounds good. Or if you have a problematic area to where you got a little bit of boominess you can't get rid of, where the notes are ringing and it's a little bit annoying, you can start, you know, at 40 hertz and go up. Is it better or worse? It's worse. Go down and you're like, okay, so that calmed that annoying, you know, sound down a little bit, and you know it's right there. But that's pretty self-explanatory. But if you do find a problem area, so let's say you have a problem area at 40 hertz, you got a little too much bass, a little too much ringing, you can remember that 40 hertz, and then this is where this channel EQ comes in. So this gives you 3 exact frequencies that you can change. So let's say you have a problem at 40 hertz, you got a little bit of ringing, the bass is a little annoying, it's a little too much. So you can go ahead and start with 40 hertz. Now 3 decibels does quite a bit, so that's just a pretty impactful number. So you noticed in your graphic EQ that if you lowered 40 hertz down 3 decibels, that helped. So you can kind of do the same thing here, but you can also now scroll through the surrounding frequencies to even pinpoint it further. So let's say you can do this while the music's playing, and maybe that song with the annoying bass or whatever that you're trying to fix. So you can go down 37, 38, and then you hear, oh wow, that's the best impact, so it's right at about 37 hertz. So once you found that exact frequency, then you can go back and adjust this further to either remove or add a little bit of that exact frequency response. And now there's 3 different settings. So if you have a couple problem areas, this DSP is nice because it gives you 3 precise EQs to tweak on each channel. Okay, so let's say you want to do -3 at 37 because that's your problem area that you're trying to fix, and that sounds good. Now we're getting into the Q factor. Okay, so what the Q is, and I'm going to put a chart up on the screen here in a minute. The higher the Q, the sharper the peak. So think of the peak, we're working with 37 hertz. So 37 hertz is at the top of the peak. So a higher Q will change the frequencies less surrounding that, because you can see it really drops off, kind of like almost like the crossovers. So it's mainly concentrating on that 37 hertz. So the higher the Q, the higher the peak. That means it's kind of more isolating that frequency. Now if you go to a lower Q to 1, it's almost going to be like the smooth roll off on the crossovers. It's going to take that peak and broaden it. So now you're changing the frequencies around that center frequency, so it's not so abrupt. So you're not changing just that specific 37 with the high Q. You lower the Q and it's smoothing that out. So it's also slightly changing the surrounding frequencies. And what that can do is give it more of a smoother sound. You may have 36, 37, and 38 are the problems. So if you lower the Q, it'll also affect those surrounding frequencies more. So just keep that in mind. Lower the Q, flatter the curve, higher the Q, sharper the peak. So keep that in mind. And that's a really awesome feature on this one, because I know the Stetsoms only give you one custom frequency for the channel EQ. So next is the phase adjustment. I had a lot of guys asking about this. This really, in a nutshell, is really only if you're going to be having like 2 subwoofers in a push-pull configuration. In a normal configuration, you know, a sub when it hits is pushing one way. So if you had 2 of them in a box using the same airspace, you wouldn't want them fighting each other. So let's say this one would be 0 phase, and then you would wire this one 180. So when they hit, they're working together. Or if you just straight up didn't have them mixed, if you just had a normal subwoofer, then you wouldn't touch it. You would leave it at 0. But if you had 2 inverted subwoofers where the magnets are outside the box, then you would run those at 180. So when they hit, they're actually going backwards and they're firing out away from the box. So that's phase. It's pretty self-explanatory. Most of you guys won't be messing with that. The next we have delay. The reason for delay is sound travels, so whatever speakers your ear is closest to, they're going to actually hit your ear first. And most of the time you guys aren't going to be messing with this, but I'm just trying to go a little bit more in depth with the settings. But let's say you have a big SUV and you have some speakers all the way in the back in the rear hatch, and those are going to hit your ear later than your front door speakers. So what you can do is you can increase, decrease the delay to the front or the rear to make the sound hit your ear at the same time. So this really is not needed too often, but that's what it does. So you can basically just adjust for how far away the further away the speakers, you want less delay, because you want them to hit the same time as the front speakers that are closer to your ears. So like I said, most of you guys won't be messing with that. This doesn't have a white noise generator, but some of the other DSPs do, and some of the guys were asking what that is. White noise is kind of, in a sense, it's a measuring tone, and what it does, it puts out an equal sound that's from 20 to 20,000 hertz, and it's all at the same level. So that way you can use a FFT linear spectrum analyzer or a calibrated microphone and run the white noise, and it'll tell you what frequencies you're missing, what frequencies are peaking. So it's basically a measurement tool, but to use white noise, you know, you need to have like an FFT linear spectrum analyzer or like a calibrated microphone, you know, like a UMIC or an Omni mic or stuff like that. So I think that covers everything for you guys. I kind of went over everything. You guys got any questions, just let me know. But I hope this video helps. Please like and subscribe. I appreciate you guys watching. This is a pretty new channel, so if you guys have suggestions, please let me know. And until next time, thanks so much, guys.